Hey everyone, in this video we're going to be looking at different forms of quadratic equation, specifically vertex, factored, and standard form. And you can see these three, and I've purposefully not said which is which, but you can see those three written there below me. All three of these equations describe the exact same quadratic function, it's just that the way we've written the equations is a little bit different. So before we get too far, let's talk about that a bit. A quadratic equation is just an equation representing a quadratic function. That is a polynomial of degree 2. It's going to have a variable squared, like you can see here, somewhere in that equation. And if we graph these, we're always going to get a parabola, that U-shaped graph. And in order to describe these, we're going to be needing a vertex and two other points from each of these equations, but we will get to that later. For now, we just need to know which form is which. And here they are. We have our three forms: vertex form here in red, factored form, also known as intercept form, here in blue, and standard form in orange. And so what I want you to notice is the general structure of these things. If we look at vertex form, we have some coefficient outside of a set of parentheses, and that quantity in the parentheses is squared, and then we have some other constant term added or subtracted back here. So one set of parentheses, and then that is squared. We generalize this by calling the coefficient a, the number that is paired up inside the parentheses with x we call h, and the one outside is k. In factored or intercept form, we have y equals, we have some coefficient again, but now we've got two sets of factors in parentheses. Now remember, if something is factored, that means it is a multiplication problem, and this is just a multiplication problem between these three quantities. And so if our quadratic equation is just written as a series of multiplication problems, we have factored form. And we can see, just as with vertex form, we've given this abbreviations. The coefficient out front is called a, the quantity that is with the first variable in parentheses is p, and then the second one is q. Finally, we have standard form, and this is exactly the same as standard form of a polynomial. There is no difference between the two. Largest exponent, which in this case will be the quadratic term, is written first, and then the linear term, and then the constant term. And just as with the others, we have abbreviations, a, b, and c, for those particular coefficients. So let's take a deeper dive looking at vertex form. That's y equals 8 times quantity x minus h squared plus k. Not a terrible idea to go ahead and learn how to say that as well. And here you can see some normal examples where a, h, and k are just whatever numbers we allow them to be. They can, in fact, be any number. But it turns out that there are some special cases we have to look at. For this first one, we consider what happens if a, the number in front of the parentheses, is 1. If a is 1, we won't have to write it. Likewise, if it's negative 1, we'll just write a negative in there. A will not ever be 0, because if a is 0, then this whole term goes away, and all we're left with is a constant, so that would not be a quadratic function. We can also look at what happens if h is equal to 0. That's how we end up with this equation right here. If that's the case, the parentheses become unnecessary, and we just write x squared instead of where we would normally find something in parentheses squared. So this is when h is 0. And we can also look at what happens when k, the number added to the end, is 0. When that's the case, there just won't be anything there. So all four of these that you see in this column are actually in vertex form. We can do the same with intercept form. You can see here where we've just let a, p, and q just be whatever numbers we want. They can be positive, they can be negative, it doesn't matter. But just as before, we can look at what happens when a equals 1. That is, you don't have to write it. or A is -1, in which case we just put a negative sign and no 1 out there. But we can also have a case where P is 0. So if I had, think about a set of parentheses where it was x plus 0, x plus 0 is just x. There's nothing else to do there. So I wouldn't need that set of parentheses, and I would just have A times x times quantity x minus q. Now likewise, we can also think about when q is equal to 0, and we would just have an x here at the end. However, you will likely never ever see anything written like this, because if we're looking at something like this, it makes way more sense to move this x over here as part of the coefficient and make the coefficient 2x times quantity x plus 3, so that it would end up looking just like this. But these two situations are what happens when P or Q is equal to 0. Finally, we have standard form, and remember this is exactly the same standard form of a polynomial. We can let A, B, and C be any numbers we want to, positive or negative, doesn't even matter, but there are some special cases to look at. A could be 1, or B could be 1, in which case we don't have to write A or B there. That 1 is understood. Likewise, if A or B is -1, then we can just write a minus sign. So here A would be -1, and B would be -1 as well. A will never be 0, because if A is 0, the x squared term goes away and it's no longer quadratic. However, B can be 0, which is what we see right here. Well, if that's the case, the term that contains the x with no exponent will just go away, and I'll be left with something like that, which, by the way, should remind you of vertex form when h is 0. So if you see something like this, you can think of that as being written either in standard form or in vertex form. Kind of interesting. Or we can allow C to be equal to 0, in which case we would just not write anything there. Now, I cannot stress enough how important it is that you have these forms memorized, that you are able to identify A, H, and K from vertex form, A, P, and Q from intercept form, and A, B, and C from standard form. Know this. This is exactly the same situation as when we studied linear functions and you needed to know all the different forms there. Know them and love them. Good luck.